Welcome to EDU World Space.
Hi everybody. This one is determine the range of values of the amplitude vibration is less than the angle of rotation caused by the static couple of magnitude Tm. So again, this is mechanical physics. And it's going about this way. So it's going about, that's called clockwise, and your T, or your torsal couple of magnitude is given in the problem as Tm sine WF. So basically what you're trying to find is the circular frequency of vibration, okay? And we're going to find this by looking at the amplitude of force vibration equation, and then the torsal spring constant, and the inertia of the disk, and the frequency of vibration, okay? That's how we're going to solve it. So let's just write everything out. We have mass, which is 8 kilograms. Get that right for you. We have the radius of the disk at 0.2 meters. The angle of rotation, which is at 3 degrees, which is also 3 pi 180 radians. Okay. And then the static couple at rotation is T equals 50 Newton meter. And then the maximum torsal Tm is 60 Nm. Okay, so like I said, we're going to find the amplitude force vibration equation. So we have that, which is Pm, okay, 1 minus frequency F, frequency N squared. And then we have theta for the angle. It's Tm, okay, 1 minus WF Wn squared. Okay. So now we can find the torsal spring constant, which is given to us as T over theta. And that is 50 Newton meters over 3 pi 80, 180 radians equals 3,000 over pi Newton meters radians. Okay, so now we have to do the moment of inertia. Which is just 1/2, 8 kilograms, 0.2 meters squared equals 0.16 kilograms per meter squared. And then we have to do the frequency of vibration, which equals K over I, which is going to be 3,000 over pi Newton meters radians over what we just found, 0.16 kilograms meters squared. And here we get 5968.31 seconds squared. Okay. And now I'm going to show you what this whole thing kind of looks like on a graph, because it's kind of important to figure out what to do next. So we have this at 1, and we also have this guy. And here we have your theta m, your theta st, and your negative st, and I'll write that down for you in just a minute. And then here, what we're trying to find is this information here, and we have f squared over n squared. And this st is this right here, okay? Okay, so from this, we're just going to write OM st 1 minus squared, and this is going to be less than st. And so from this, you have your positive st is going to be less than the negative st times 1 minus f squared n squared. And we have 1 minus 1 plus f squared n squared. This is a minus 1, if I can get it here. Okay, and because what you're doing is just, if you just do divide this over, and you remember how it kind of crosses out, but you still have this negative, so it just leaves 1. So we have 2 f, and we're doing the positive, so we don't have to switch the sign around if you're curious. N squared, so we get 2. Okay. So now what we'll have is here. Now see how we're switching around? 2n squared. And here equals 25968.31 seconds negative squared. Oops. Second to negative squared. And here we get 109.3 radians per second. So this is going to be greater than that, okay?